Okay, so let's review what we've gotten so far. If this is our function, we want to know what the effect of the graph on the graph of the parent function was. Well, the parent function, remember, is f of x equals x squared. So we know what that looks like. When we put a negative in front, if you remember, we go back to this first page where we put a negative in front, that makes it open down. So we're going to say here, effect on graph of parent function is it opens down now instead. Okay, when we put in parentheses, this is kind of strange, but when you put a number in parentheses with the x, and then the squared is outside, it's going to move it either left or right. But when it's in parentheses, it's going to do opposite what you'd think. When I see a plus h, I'm automatically thinking, well, it's going to move to the right. But since it's in parentheses, it's going to do the opposite, and it's going to move to the left. And let's look and see if that happened. When we put a number in parentheses with the x, and it said x plus 2 in parentheses, it actually moved left 2 units. So in parentheses, it's going to do opposite. So this one is going to move left. Instead of 2 units, it's h here, so it's going to move left h units. The next one, also in parentheses, so it's going to move left or right. In parentheses means left or right. But this one says minus h, so you would think it's going to move left, but since it's in parentheses, it does the opposite. So let's look and see what happened over here. When we put a minus 2 in the parentheses with the x, it made it move right 2 units. And so that's exactly what's going to happen here. When we do x minus h squared, it's going to move right h units. Whatever number that h is, that's how many units it would move right. Okay, the next one is h of x equals x squared plus k. K could be any number. Let's see what happened when we just added a number to the x squared. If we added 2, it moved up 2 units. So if we add k, it's going to move up k units. Whatever number that k is, that's how many units it'll move up. F of x equals x squared minus k. Well, when we did minus 2 here, we just tagged on a minus 2 to the x squared. It made it move down 2 units. So that's exactly what's going to happen here. It's going to move down k units. When we stuck a number in front of the x squared, if that number is bigger than 1, so if a is greater than 1, it will make a vertical stretch. It will stretch it out like Play-Doh. If that number is between 0 and 1, in other words, if it's a fraction like this one, then that means it's going to squish it down. So if 0 is less than a is less than 1, that means if a is between 0 and 1, that's going to be a vertical compression. Okay, so we have vertical stretch. If a is bigger than 1, that number in front. And a vertical compression if that number in front is a fraction or smaller than 1. But it can't, if it's negative, then that's just going to turn it over to the opposite. It's going to make it open down. Okay, think about that for a minute. Okay, so now we're going to look at putting some of those changes into a graph of a parent function. I've got my parent function graph here. I'm not going to fill in my table because I have that on the first page. We're just going to graph this. Remember that your parent function starts at 0, 0. But let's see what's going to change here. If I put a negative in front, that's going to make it open down. So it's going to open down. If I put a minus 3 in parentheses with it, parentheses means it's going to move left or right. In parentheses means it says opposite what you think. So since it says minus 3, it's going to go right 3. And then if I tag a plus 1 on the end, it's going to go up 1. So I'm going to take my vertex, which was at 0, 0, and I'm going to move it right 3 places. And I'm going to move it up 1, and I'm going to put my vertex right there. Okay, now I'm going to use my parent function pattern where I go up 1 over 1, up 3 over 1, but I'm going to do it upside down because it has to open down. So I'm going to go down 1 over 1, down 1 over 1 the other way, and then from there down 3 over 1, down 3 over 1, and that is the graph of this function up here. All I did was I incorporated all these changes. I made it open down, I moved it to the right 3, and I moved it up 1. My vertex is what I moved, up 1 and right 3, and then I made the whole thing open down. And I used the pattern of up 1 over 1, up 3 over 1 to get my points. I don't have to do a table anymore. It's pretty cool. Now let's look at our domain and our range. Domain is what values are covered on the x-axis. Well, this graph goes down and out to the left forever and down and out to the right forever. So since it goes to the left forever and to the right forever, my domain is negative infinity to infinity. Okay, my range is up and down. How far down does this graph go? Remember, we want to start with the smallest value. These arrows means it goes down forever, so it would be from negative infinity. And how high does it go? Well, it looks like it goes up to here. That is at 1. And yes, it does include the 1 because it actually touches there, so that would be a bracket. Okay? All right, let's look at the next one. Number 16. Graph h of x equals 2, parentheses x plus 4 squared minus 2. I'm not going to do this because we have that already. So what we're going to do is we're going to figure out what are my changes going to be. Well, the 2 in front is going to give it a vertical stretch by a factor of 2. So when I'm counting my pattern numbers, up 1 over 1, up 3 over 1, I'm going to multiply everything by 2. Okay? Then the plus 4 in parentheses means I'm going to move right or left in parentheses, and it does opposite what you'd think. Plus 4 makes me think right, but I'm going to do the opposite, so that would be left 4. And then the minus 2, I'm going to go down 2. If you have any questions or you're confused, make sure you stop me. Okay, here we go. So we're going to start our vertex on a parent function starts at 0, 0. I'm not going to worry about the vertical stretch until I start doing my pattern. I'm going to move left 4, 1, 2, 3, 4, and I'm going to go down 2. That's where my vertex is going to be. Okay, it's going to open up because there was no negative in front. So instead of going up 1 over 1, I'm going to double that because I have a 2 in front, which is a vertical stretch of 2. So I'm going to go up 2 over 1, and then the other way. And then instead of going up 3 over 1, I'm going to double it, and I'm going to go up 6 over 1. 1, 2, 3, 4, 5, 6 over 1. I'm going to do the same thing here. 1, 2, 3, 4, 5, 6 over 1. And that is my new graph. Boy, I can graph these quickly if I know these tricks. Okay, domain, x-axis. How far left does it go? How far right does it go? Arrows means it goes forever. It's going up and to the left forever, and this is going up and to the right forever. So my domain is negative infinity to infinity. Range, up and down. How far down does this go? It does not go down forever. It stops at negative 2. It does touch negative 2, so it includes negative 2, and it goes up to, arrows means it goes on forever, to infinity. And so I've just graphed these. Okay, now let's look at writing equations from some instructions that they give us. So it says write the equation for each of the following. Start with the graph of f of x equals x squared. So the first one says shift 3 units left and 6 units down. Okay, so I'm going to start off with f of x equals. When you write an equation, always write f of x equals when we're doing this, because if you don't, it's not really a function or an equation, it's just an expression. So you have to write that in there. Okay, 3 units left. That means I'm going to put in parentheses, I'm going to have x. Left means, remember that it's opposite when it's in parentheses, so that means I'm going to say plus 3, and then don't forget your squared, because you have to get the x squared in there to make it a parabola. And then if I want to move 6 units down, I'm going to just say minus 6 at the end, and I have my equation. Okay, the next one. Reflect over the x-axis, stretch by a factor of 3. When reflect over the x-axis means I'm going to open down. Okay, that's what that means. And probably I should have said reflect over the x-axis before, but I said open down. That's okay. All right, so if I reflected over the x-axis, to do that, I need a negative in front. So f of x equals, I'm going to do a negative, And then a stretch by a factor of 3. That just means I'm going to stick a 3 in front of my x squared and I'm done. So f of x equals negative 3x squared. All right, shrink by a factor of 1/2. Shrink means compress, squish. So, and then 3 units right and 2 units up. So start off with f of x equals. Okay, shrink by a factor of 1/2, compress by a factor of 1/2. So I'm going to put a 1/2 in the front. And since I'm going right or left, I'm going right, I have to do parentheses. Right, I would think means plus, but remember when it's in parentheses, you do opposite. So it would be x minus 3, close your parentheses, and don't forget to square it. That's where we get the x squared from to make it quadratic. And then 2 units up, I do plus 2 at the end. So a common mistake is to forget that squared there. Don't forget to do that. Okay, this next one, reflect across the x-axis, stretch by a factor of 2, shift 2 units to the right and 3 units up. So what we're going to do, start off with f of x equals, reflect across the x-axis, that means opens down, stick a negative in front. Stretch by a factor of 2, put a 2 in front. 2 units to the right, right left means parentheses. Right, I would think means plus, but since it's parentheses, we do the opposite, so it would be x minus 2, and then squared. Don't forget that squared. That's the most common mistake here. And then 3 units up, plus 3, and I have my equation. Okay. All right, let's look at this one. Now we're going to take a graph and write an equation from it. So we need to figure out what's different from the parent function. Well, first of all, it opens down. So we're going to write opens down. That means there's going to be a negative in front. Look to see if there's a stretch or compression. So look at your pattern. This is down 1 over 1, down 3 over 1. That's my pattern. So there's no vertical stretch or compression. I did have to move to the right 1, 2, 3, 4. So I moved right 4. And I had to move up 1, 2, 3. So I'm opening down, I'm moving right 4, and I'm moving up 3. So my equation, my function is going to be f of x, don't forget to put f of x equals, opens down, I stick a negative in front. Right 4, I got to have parentheses. Right, I would think means plus, but since it's in parentheses, it's opposite. So minus 4, don't forget to square it. That's where the quadratic part comes in. That's what makes it a parabola. And then up 3, I plus 3. And there you go. All right, let's go to, that's it. We're done. Okay, tomorrow we are going to work on an assignment over this. So make sure you have these notes with you. If you have any questions, now is a great time to ask me.